Radioactive pollution. Radioactive pollution is a special form of physical pollution related to all major life-supporting systems, air, water, and soil. Emission of energy from radioactive substances into the environment is referred as radioactive pollution. It is also called as nuclear hazards. Radioactive pollution or nuclear hazards uh, have the same meaning. Sources. First we see about sources, effects, control measures, and we see a nuclear accident which has happened in Chernobyl. So sources of nuclear radiation or radioactive pollution, it is categorized into two, natural as well as anthropogenic. Anthropogenic means man-made sources. So when we come for natural sources, first one, cosmic rays from outer space, radioactive radon, then soil, rocks, air, water, and food. Anthropogenic sources, first one is nuclear power plants, then nuclear accidents, X-rays, health diagnostic kits, and testing laboratories. So these are the pathways where man is exposed to various types of radiations. Natural sources, which contributes to 81%, that includes 55% from radon, then external sources and internal sources like potassium 40, carbon 14, etc. Man-made sources, around 90%, it comes from medical diagnostic X-rays 11%, nuclear medicine 4%, then consumer products and other fallout. Sources of nuclear radiation. So the main source of nuclear radiation is nuclear power plant, and that is particularly from core and coolant of the reactor. The fission products produced during normal operation of nuclear power plant remain within the fuel elements and also in the nuclear waste. And the problem in case of nuclear power plant is how to store and dispose the radioactive waste, and real problem is the avoid of possibility of accidents. Radiation is also emitted from radioactive materials such as uranium radon gas that occurs naturally in the earth crust. The radioactive waste or the radioactive contaminants decay by beta emission. The contamination occurs due to leakage from the reactor, and contamination can also take place due to coolant leak, and it causes emission of radioactive gases. Radiation hazards may also occur at the time of overhaul of the reactor. Physiological effects. What are the physiological effects when we face when we are exposed to nuclear radiation? So no observable effect will be there if the radiation exposure is less than 0.25 GY. So 0.25 GY is nearly 7 times average annual radiation exposure. So when radiation exposure is in the range of 0.25 to 1 GY means white blood cell count, it will drop. Then 1 to GY absorbed dosage means you will have mild radiation sickness like nausea and vomiting, headache, fatigue, weakness. Then moderate radiation sickness, it will be caused due to exposure to 2 to 3.5 GY. And that will have nausea and vomiting within 12 to 24 hours, fever, hair loss, vomiting blood, bloody stool, poor wound healing. Any of the mild radiation sickness can be fatal to sensitive individuals. So if the individual is very sensitive means mild radiation sickness will be very dangerous to them. Severe radiation sickness, that is when radiation range is in the range of 3.5 to 5 GY means nausea and vomiting, it will be happen in less than 1 hour. Diarrhea, high fever, any symptoms of lower dosage exposure will be there, and about 50% of fatality will be there. So around 50% of the people will be very sensitive to this radiation sickness. Then very severe radiation sickness 5.5 to 8 GY. So nausea and vomiting, it will happen within 30 minutes. Then dizziness will be there, disorientation, low blood pressure, and you can have any symptoms of lower dose expose, and fatality rate it will be more than 50%. And longer chronic radiation. So if radiation is exposed to for longer time means that will cause genetic mutations. It will lead to formation of tumors, cancers, birth defects, cataracts, etc. So what will be the effect of radioactive pollution means? Already we have discussed. So if low level radiation exposure will be there means it can increase the risk of cancer and other disorders. The radioactive emissions can penetrate biological tissue and it can cause damage and prevent cell division. Very high dosages of radiation, it may totally destroy these cells, causing immediate death. Lower dosages may damage DNA. The very important thing in our life, the genetic substance inside the cell, if this has been damaged means this will form malignant tumors and leukemia. And radiation exposure, it also weakens immune system. It causes mental retardation and development of cataracts. So all the above health hazards and adverse effects, they are directly related to the level of exposure. So the level of exposure will vary the impact of the radiation on the humans. So the dosages in the range of 10 to 15 EM result in the increased risk of cancer. So how to control radioactive pollution? So radioactive pollution control is from natural sources is difficult, but we can reduce the level of pollution from man-made sources. So how means we can develop protection against radiation exposure. So the three factors which will influence radiation protection are the distance from the source. So we have to maintain a considerable distance from the radiation source, and we have time of exposure. We have to reduce the time of exposure of radiation, and next one is shielding. So proper protective shielding will reduce the impact of the radiation. So this is what it is mentioned in this slide. So less time spent near source, then greater distance from the source, then behind the shielding. So the other ways how we can control radioactive pollution is that we can use laboratory hoods, air filters, exhaust systems. We can eliminate dry sweeping, wearing protective cloth, radiation indicators. Then we can use respirators, and we have prohibit smoking and eating where radioactive materials are used. Then accessibility to areas which are susceptible to radiation exposure should be controlled. So if any radioactive exposure area is there means it must be given appropriate signboards like restricted area or radiation zone. And we have to reduce the accessibility to that areas. Then radiation resistant enclosures and barriers are to be placed for screening workers from the radioactive materials. So we are going to see one of the important nuclear radioactive disaster which has taken place in Chernobyl in 1986. So this has been considered as the worst accident ever in the history of nuclear power. And this has released more than 100 times the radiation produced by the atom bombs of Hiroshima and Nagasaki. And this has affected Western Soviet Union, Eastern, Central and Northern Europe, Eastern and Northern America. 336 people have been evacuated and resettled elsewhere. So the ecological effect due to that disaster is that the radioactive waste had been floated in an easterly direction. It has been traveled as far as Sweden. So it has traveled around 1100 kilometers. So in case of Soviet Union, 60% contamination of the radioactive waste has been reported in Belarus. River Pripyat and Dnieper river reservoir system has been completely contaminated. Freshwater fish has been contaminated several times the safe limits. The pine forest within 4-kilometer radius of the Chernobyl area, it has turned ginger brown and it has been completely destroyed. Human effect, when you go for the human effect of this disaster, 336,000 people has been evacuated and resettled. 237 suffered from acute radiation sickness. 31 deaths has been reported within 3 months. 9,000 cancer death has been reported. 4,000 thyroid cancer cases among children by 2002. So what are the safety measures we can take in controlling the radioactive pollution is that monitoring radioactivity around the disposal sites, prevention of erosion of radioactive waste disposal sites, prevention of any drilling activity in and around the waste disposal site, then periodic and long-term monitoring of such disposal sites. Thank you.